Hey, Gan. It's been a long time coming. I think that will continue to be a common theme for these new videos, at least for a while. It really has been a fat minute since I visited these games. And this one is one I missed quite a lot. Universe Sandbox 2. I have seldom experienced a simulator that has so reliably forced my racing mind and unreasoning panic to just stop and get reacquainted with a feeling of perspective. I also don't think I've opened this simulator without feeling small the second the Earth comes into view. And hearing this soft, gentle music in the background all the while, I'm glad it's there. It gives a positive spin to this small feeling. It helps me to be glad that this small place even exists at all, and that I get to live on it and play my small part in it. Really encourages something good in me, and if previous comments on my older videos of this game were anything to go by, it seemed to do it for a lot of you, too. So, why not go exploring once again? Plenty has been changed, and I have plenty of things to discuss. Come and see! First up, we have to find... Where is it? Where is it? Where is it? Oh, there it is. James Webb Telescope. Oh, it's so shiny. It's a funky looking device, isn't it? Launched, I believe, quite recently. By NASA, obviously, and was even named after one of the old NASA administrators, James E. Webb. In case it isn't obvious, that's a lot of gold. Very reflective, very resistant to corrosion. For decades, we've relied on the Hubble telescope to do all of the detecting of really far away stuff. This one is far better at doing that. Apparently, little tidbit here, it can detect things 100 times dimmer. Distant stars, galaxies, planets, you name it. Anything that the Hubble can't pick up, this will. And I feel like we're going to find out a heck of a lot more about the universe around us with this. It's so weird looking. It's like a coffin. Minus the morbid part, though. It's a coffin with a cool looking telescope on it. Man, expensive, but I really feel like it's going to pay for itself. Yeah, it's just happily chilling around Earth. There we are. Yeah, that's a really nice view, actually. Look at that. That's a really nice view. Oh, marvelous. Oh boy, oh boy. Now, there's another spacecraft I'm just going to have a little squiz around for. It is no longer in the heliosphere. Actually, that's an interesting word. Heliosphere, as in the sun god Helios. And you will also note that there is a chemical called helium. You've heard of it before. Its discovery was because a scientist in the 1800s using a spectrometer looked at the sun during an eclipse, mind you. Using the spectrometer, he looked at the sun and found there was a lot of yellow. What he was looking at was, at the time, a new element that hadn't been discovered. So that scientist was like, oh my goodness, I found something new. What could the sun possibly be giving off? And to shorten that inevitable long story down, that scientist, I believe, or maybe it was a team, I'm not entirely sure, then decided to name it helium. There's quite a few Greek god names for elements and planets, and well, yeah, that was no different. And he was absolutely right. There was an element coming off the sun. It was helium, because, obviously, there's lots of hydrogen in the sun. When those two things fuse together, there's two protons. That's helium. And it being a noble gas, when it's heavily charged, it glows yellow. Which is, I guess, what gives the sun its yellowish tinge, especially when it has a solar flare. So yeah, I don't know, I just thought that was kind of cool. I really love the naming of all these things. I don't like how we've gone to barcodes, like, 2003, 2005, Go back to Greek gods! If there's not enough, make more! Come on! It's so cool! Voyager 1, where are we? Oh, jeez. Whoa! Okay, buddy. Settle down, mister. I've been endlessly curious about this. Just wanted to see... Oh, he's a little dark. Hello! I remember many years ago I spoke about this. So for anyone watching my whole playlist of Universe Sandbox videos, first of all, thank you, you're the real OG. Secondly, I've already spoken about this, but I just wanted to catch up with this little fella. Wanted to see how far away it got before I found it. Wait, is that... Oh, those are the stars reflecting off the big old dish. That's beautiful. I'll change the lighting to surface illumination. There we go. This goofy looking thing. Oh, with its golden record on the side. Oh, that's so cool. It's got instructions and all on how to actually operate the record, just in case anything finds this. Kinda hope it does. That would be really nice. This is the most distant human-made object from planet Earth. It is outside the sun's influence. It's been out of the heliosphere for nearly a decade now, actually. And that was announced in roughly 2012, 2013, when it sent back some really fascinating data. One of these devices hanging off of it can measure plasma on the outside, which is obviously what stars give off. And it noted that in interstellar space, the outside of the heliosphere, the plasma kept getting denser and denser, which to me sounds counterintuitive, because wouldn't there be less things out there further away from our sun? But then again, there are other stars around, so maybe their plasma is being spread all over the galaxy, and the sun with its influence is able to push it back. Ah, so it forms a bit of a barrier, like a bubble. And when it went outside the bubble, the outside air, or the outside space, was different. And one of the coolest things this thing sent back to Earth, through a very deep network, still talking to it even to this day, goodness me, was some electrical signals being charted on a graph from late 2012 to early 2013. In 2012, the plasma noise was a bit low, and later on in early 2013, the plasma noise was louder. And one of the greatest things is that it made a sound. And it is one of the eeriest and coolest sounds I've ever heard of this little spacecraft going beyond the sun's influence into literally unknown territory. And it told us what it felt like, and this is what it had to say. Now, I don't know what that feels like, but I imagine it's a bit like being dropped out of the nest. And obviously there's Voyager 2 down there somewhere, but I'll only speak about this one for now. Apparently it's only got about 3 years left of power. It'll only be able to power some of the leftover instruments on board until about sometime in 2025, which is staggering if you think about it. That's a nearly 50-year-old piece of plutonium still being hot enough to produce some electricity. And this thing's still being able to speak back to Earth and tell us what's up, what's going on out in the great beyond. That's a friggin' reliable machine, this. It was even apparently using its thrusters in 2017 to, readjust itself. And they hadn't been fired since the 80s, and yet they still worked flawlessly. And it runs itself, it thinks for itself, it adjusts its own course, and it still receives age-old instructions. All this from the 70s is just amazing. So you could imagine when New Horizons down here also gets into interstellar space, the sort of things we can expect to hear from it. I think we're going to get some really cool signals. Because this is the one that did a flyby of Pluto several years ago, and it was and it took some very nice photos of it. You should really have a look at them, actually. So another thing, I've turned orbits back on, and obviously the straight lines are probably going to be satellites yeeting it on out of here. But you'll notice one very weird orbit is this egg-shaped thingy here. That's Sedna. I don't know if I don't know if I've had a good look at this little dwarf planet. Let me turn, alright, realistic. We'll go back to studio lighting, there we go. So this little dwarf planet is actually, hang on, recheck the orbit. As of recording. Oh, it's actually near its closest point. So we could actually have a good look at this. I don't know if that's what it actually looks like. I'd hope so, because that's kind of cool. Little green planet. Earth similarity 5.28%. Life likelihood nil. Okay. Oh, but it's such a shame. What a beautiful weather out here. Damn it. So one of the things that's been added to this game is another little experiment. In this scenario, there is a tidally heated, habitable moon. Let's have a look at it. So here's the sun, and here's all the habitable zones, obviously. Bit of a Goldilocks scenario here. Red too hot, blue too cold, green just right. We're beyond blue. This is pretty cold out here. There's an icy fella. We're getting sunlight, but not very much. It's a bit miserable here. Everything's frozen. There is water, there is land, but it's all frozen, and it would take a miracle for life to ever be happy here. Whereas this planet, over here, is orbiting a gas giant, and the gas giant is, well, quite massive actually. Same mass as Jupiter, a little bit larger than Jupiter, much higher radius there, and this planet is, well, it's its moon. And I guess the heat from the gravity pulling this planet and forcibly moving water around, that produces enough friction to melt all of the ice. It's negative 12.5 degrees. Still pretty chilly, but it's not negative 170. Merely the friction of gravity alone is enough. I hadn't even pondered that before. That's so cool. Oh man, that's a pretty sizable country, I guess. I really like these new measurements here, actually. They're comparing them to planets, not in just how many gajillion kilometers they are. And I guess there'd be a decent enough atmosphere as well to keep all that in. Composition, appearance, atmosphere, clouds. City lights? Oh, that's sick. That's really cool. I just realized, hang on, this thing is actually tidally locked to the sun, even though it's spinning around this gas giant. Oh, this is a really cool option, city lights. What if we already lived here? What would it look like at night? I guess these people are in eternal darkness. That's a little bit miserable. I take pity on this already habited planet and everyone living in eternal darkness, so I will make you a spin. Rotational period. We'll change that to days, and we'll just have one day. Go on. Make a day of it. I fixed a planet. And everyone in Morp is very happy. That's a freaking great name for a country. What are you talking about? Right. I've had enough of repairing the universe. My goodness, what a burden. I suppose we should check out another fantastic achievement. Whoa, bit of a blurb there. This strange device is called the Parker Sun Probe, named after Eugene Parker, who I believe discovered the solar wind phenomenon. And as I'm sure you've probably heard before, this little fella is to orbit the sun, get as close as possible, and study it. But obviously the sun is extremely hot, 5,500 degrees Celsius, so you're gonna need a lot of shielding, which is exactly what's on the front here. This is some sort of very thick carbon-based material covered in an extremely reflective coating that shields all the instruments back here from the sun's extreme radiations, especially at really close distances. And it's going to be not just the closest man-made thing to ever approach the sun, but it will also be the fastest moving thing, at least for a time. And in a few years' time, the probe will get, let's see, this will be its closest approach. On Christmas Eve 2024, the Parker probe will be at its closest point to the sun. Distance 0.4, just over 0.4 AU. AU being the distance between the Earth and the sun. That is insanely close. Whoa. Dude. Ah, toasty boy. Okay, according to the sim, we're at 1,000 degrees Celsius. The heat shield at the front apparently can withstand 1,300 degrees. And you'd think that's just a bit too close for comfort, but everything I'm reading has suggested that the instruments will be 100% protected, or as protected as possible. And even if it goes off course a little bit, they have automated a lot of safeguards in place to correct itself. And it's just as well, because if this thing were to receive instructions from Earth about what to do, that would take 8 minutes to get here, to send signals to this little computer on board and tell it what to do in order not to burn to death. If this is the way that I think it is, I think how it does really minute adjustments of its trajectory is through momentum wheels, which are actually physically spinning wheels on the inside of this thing. And I guess they could spin faster or slower to sort of, in some sort of physics wizardry, make one side sort of heavier or lighter. It makes sense to me because I've been riding dirt bikes pretty much all my life, and I noticed that when you jump in the air and you rev the engine, the rear wheel spins faster, and therefore there's more centrifugal weight, and it brings the back of the bike down, because it's much better to land on the rear wheel than it is the front wheel when hitting the ground. I would assume this works in a very similar way. Makes sense to me anyway. But even if that isn't correct, what is correct is that it can do it itself, and that is the important bit, because you don't want to fizzle out and die that close to the sun. This thing can only speak to Earth sometimes, because it's either angled at the wrong angle to protect itself from the sunlight, that it can't speak to Earth, or the radiation from the sun is actually interrupting the signals between it and Earth. So that's a whole nother factor that you gotta consider, being that close to the most powerful thing within light years around us. Just brilliant how they managed to actually make something that's currently in space. Hang on, where would it be right now? Closer. Closer. Oop, fourth. Now. Okay, we're on the 4th of March. We're pretty far away right now, actually. Still looking at the sun. Hello. Oh yeah, I mentioned before, this is going to be, at least on its closest flyby, the fastest thing that humans have ever made, because it's going to slingshot something chronic when it gets to this point of its orbit. I noted the speeds here before. Yeah, 200 kilometers a second. That would be fast enough to affect time, right? Even just a little bit. Like if this had an onboard clock, it would be slightly different, wouldn't it? Oh man, the questions. I'm supposed to show you things and have all facts, but I just got more questions. If it's going 200 kilometers a second, yeah. No, it makes sense. Makes sense. In any case, this is a really cool thing. This is a really cool device. You good job, little fella. You do good. Another thing to show you is a comet that, hang on a minute. Is it really at that angle? Oh my gosh. That's really cool. Okay. So apparently, according to this little blurb, this little comet right here made a close approach to the sun on July 3rd, 2020, 2 years ago. Woo! Marvelous. And being affected by the sun's gravity, it actually got relatively close to Earth. Hi! And closest approach to Earth was July 23rd. I went past it, bugger. Please pretend that it's July 23rd, 2020, even if you don't want to. Thank you. And for a few nights, it was actually visible to the naked eye. So there was me at nighttime just going, oh, where is he? And I look up. There it is. And there's this white little speck up in the cosmos. This end was lit up. So I tried filming it. I tried friggin' taking photos of it. I couldn't. I had garbage cameras. I just could not pick it up, but it was one of the coolest things. And apparently this one's orbit is so long that we're not going to see it for a long time. 5,000! Okay, 5,000 years and this comet will be coming back. I'm sure we'll all care about it. Another close approach of Earth. Okay, so in 6994... Beautiful. So that comet, if you did see it, congratulations. That was yet another once-in-a-lifetime thing that you got to witness. We might have just had enough of all these once-in-a-lifetime incidences. But at least this one was pleasant. So thank you, little comet. Thank you, Neowise. And speaking of distant visitors, the Apophis asteroid. I spoke about this at one point. Oh gosh. That's way too close. According to this blurb here, Apophis will visit planet Earth in 2029, but there's a very high chance that it will miss. And a very small chance, says there 2.7%, that it will hit us. I hope it doesn't, because that'll go off with the power of 500 Tsar bombs all at once. Now, even if it is very close to Earth, there are things we can do about it, I'm sure. We'd only have to alter its trajectory slightly. It isn't the biggest thing in the world. Its radius is only 162 meters. We could very well affect this thing's trajectory if we had to. But one thing I didn't do last time was a worst case scenario. 30.9 kilometers a second, that's pretty fast. What if this monstrous thing hit Earth? How screwed would we truly be? Because the Tsar bomb was pretty big, and this is 500 of them. Let's find out what happens. Oh no, I'm gonna hit WA! The horror! Oh, look at the shadow! Okay, I can't zoom in any further, so brace for impact, you guys. Been fun. I used to live there and I swore never to go back, and, well, now you know why. 5, 4, 3, 3 again, 2, 1. Go. Wow. Oh, wow. Whoa. Oh, gosh. Okay, at first I was going to be like, what are we so worried about? And then this. Oh, man. This has only been like half a minute. Bro! Look at these shockwaves. No! Don't touch me! I'm out here. And I don't want to be... Oh. Okay, the entirety of Australia felt that shockwave. Shrapnel, all that. And out here, it's probably, yeah, dissipated into the ocean there. But out here, it's kept going. Might hit some cuzzy bros down here. I'll go up here to New Guinea. Oh, wow. Speed up the time a little bit. Whoa! Okay, finally dissipated around here. Wow. Okay. There'd be, yeah, there's a little birthmark there that we have. When did Australia have a butthole? I don't remember that. There would be at least a few dead cattle out here. Should be hamburgers everywhere. But luckily, Western Australia really isn't populated at all. Everyone sort of lives down here. So they'd be away from the initial blast, I guess. But, maybe they wouldn't survive so well. This is not fitting music for the occasion. Suppose on a more light-hearted note, I want to check out our local group. This might be a bit chuggy. Oh yeah. Oh yeah. Galactic... Whoa, there's heaps more than I thought there was. That's so cool! It's really chugging my graphics card here. I mean, it's literally rendering heaps of galaxies, so... Good job, little 1050 Ti, you're doing a great job. I'm giving her all she's got, Captain! The simulation features 19 of our 60 galaxies that have been identified as members of the local group. Fascinating. So here's the Milky Way. We're surrounded by quite a few neighbors. Where's Andromeda? What? Really? Is it that far away? Oh gosh, there's always news like, oh, we're gonna collide with them in like a billion, trillion, kajillion years. What's everyone so worried about? Settle down, you muppet. That's ages away. Oh wow, look at that. Oh man. It's so chuggy, but I love it. So these are only the 19 closest galaxies to us, but we have apparently 60 in our local group, so I don't think we should care too much about the distant galaxies, because it's probably physically impossible for us to ever visit them. Study them, sure, while we can, but they're moving away from us. Space-time itself grows ever more. There will one day, 1 year, 1 millennia, be so much space between us and distant stars and galaxies that, well, even if we did invent light speed travel, we would never reach them. they would be moving further away from us than light can travel. So, if we're interested in other galaxies, I think Andromeda is it. Really, and maybe a handful of tiny galaxies just hovering around us. Because you can't mess with space-time. We have to travel within the confines of its fabric, but if it's adding more fabric faster than light can travel within it, then we don't have a chance. We'd have to consult God himself. That's the only way. Marvelous. Alright, I'm gonna give my computer a break and go back to a familiar thingy. This is probably the last thing I have to show you today, actually. Welcome back to Pulsar Stars. In the last video I ever did on this series, I spoke extensively about these little things. They fascinate me to no end. Dense little objects, collapsed stars, 12-kilometer radius, but with the mass of 1.8 suns. And yeah, this is about real time. They really do spin that hard. If you'd like to hear me go on about how these form and how they all work, and to hear some really cool pulsar sounds actually, I recommend checking out the last video I did on this series. Out of all of it, I'm probably proud of that one the most. I even got the attention of the Universe Sandbox team on Twitter, which was really, really cool. What I have to show you, as a sort of continuation from that old video, is that someone in the comments listed an even faster pulsar star than the fastest one I played. Please excuse the name Taylor, it is not the Taylor pulsar. This one is called PSR J1748-2446AD. It was discovered in 2004 and confirmed to be real in 2005. It is the fastest spinning pulsar star ever found, at a whopping 716 times per second, or once every 0.00139 so on seconds. This is absurdly fast. The surface at its equator, it's spinning at approximately 24% the speed of light, 70,000 kilometers per second. I don't even know, like pulsars are dense. Like look at that little ball of death there. That's pretty dense, but I don't know if that would actually remain spherical at those speeds. But anyway, 716 times a second. The previous pulsars that I spoke about in the last video were actual recordings from scientists, but they have not for whatever reason recorded this one, and I think it would make a fascinating noise. So what I've done is I've generated a sound and added a few layers of radio-ness to it, so it sort of mimics the old sounds. So if we could take every pulse that this thing sends to us and convert it into an electrical frequency, this is what the star would sound like. It still shocks me that something so violent, so terrifying, could ever exist. For real. It's so fast I can't even properly render in the amount of spins it's doing. 716 times a second. This is nuts. I must say, the devs behind this game have made it look a little better since last time. That's really cool. Oh, but if there's one thing, I've written to the devs, because when you exit the game you get a little how did we do thing. Obviously every review of mine is positive, but one thing I've always wanted them to do is to add a listen to this pulsar option, where it, you know, creates a blip every time it goes around. That really helps in understanding just how petrifying these objects are. They're so violent, so terrifying, yet so constant and magnificent at the same time. So freaking cool. Editing Batesy would have already chopped in the sound. I have no idea what it sounds like. I can't wait. Radio. I'd say we're done here for the day. I've even spent so long, the whole solar system came back to life. Okay, I'm definitely in this star's habitable zone, but I didn't expect us to look all blue. Oh, that's sick! Seizure warning. I'm gonna turn it on to realistic. Yeah, we don't have an atmosphere anymore. This pale blue dot is now a deep blue, UV purple dot. Hope you're a fan. And really, I hope you've been a fan of this return to Universe Sandbox. It's been really fun going through this and sort of nerding out about everything. And I'm really surprised and happy that this game is still being updated religiously, even still. Really is a brilliant simulator. If you want to try it out for yourself, hop on Steam and go get it. Really good. You'll really get a feel for just how amazing the universe is around us. And just how darn lucky we are to be in this one little spot. If we orbited a pulsar star, we'd be dead. I'm not seeing much green anymore on this planet. We live on the most unlikely miracle of the universe. So, yeah. While you're still around on this weird little blue ball, have a good one. That will make your time here absolutely worth it. See you later.